Good afternoon, students. Today we are going to discuss. Today I'm going to teach about the yarn manufacturing. The objectives of today's class are classification of yarns, different yarn numbering system, definition of yarn count, quality parameters of yarns. So this is about Unit 2, and today we are also going to start Unit 3, that is elements of fabric manufacture. In this, the objects are methods of fabric manufacture, flowchart of weaving preparatory process, process stages of weaving preparatory, and definition basic terms in weaving like warp and weft. So, classification of yarns. So, yesterday we already discussed spinning, how the yarn is going to obtain. The sequence are blow room, carding, combing, drafting, draw frame, roving or ring frame, speed frame, and yarn. So today the first objective is classification of yarns. You can see in the slide that is classification of yarns. It's divided into staple spun yarn and filament yarn. In staple spun yarn, by fiber length, short staple less than 60 millimeters and long staple will be more than 60 millimeters. And by construction, the yarn is classified into single, plied, corded, cabled combination. And by spinning system, the yarn is classified as ring spun, OE or rotor spun, core spun, edge spun, friction spun. In the case of filament yarn, the yarn is obtained when the number of filaments, again it is classified into monofilament and multifilament. So this is the classification of yarns. So again I'm going to tell classification of yarns. Classification of yarns is classified into short staple yarn, or staple spun yarn, and filament yarn. In staple spun yarn, it is the five yarns are obtained by fiber length, that is it's classified again into short staple, which is less than 60 millimeters, and long staple greater than 60 millimeters. And by construction, yarn is classified into single, plied, combed, carded, and combination. And by spinning system, yarn is classified into ring spun, rotor spun, core spun, edge spun, friction spun. And the second classification is the yarn is going to come classified in filament yarn is when the number of filaments. It is classified into monofilament and multifilament. So this is about classification of yarns, first objectives of today's class. Then next, short staple. That is staple spun yarn. These are made by twisting staple fibers together into a strand. The length of the fiber is limited. Given are some of the spun yarns. So monofilament. Monofilament is single, solid, single strand of unlimited length is called mono yarn. So in staple spun yarn, it is classified into mono yarn, multifilament yarn, staple yarn, and so on. So mono yarn is solid, single strand of unlimited length. And multifilament is many continuous filaments with some twist is called multifilament. The staple fibers are many short fibers twisted together tightly is called staple yarn. And two-played yarn, two single yarn twisted together is called two-played yarn. And multi-played yarn is played yarns twisted together is called multi-played yarn. Thread. Thread in first unit we already learned the definition of thread. So here it is known as hard fine played yarn is called thread. And last one is cord or cable. Cord or cable is many played yarns twisted into a core structure that will be strong one. So these are the staple spun yarns, class staple spun yarns. So, mono yarn is what? Solid, single strand of unlimited length. Multifilament is many continuous filaments with some twist. And staple yarn is many short fibers twisted together tightly. And two-played yarns, two single yarn twisted together. Multiplied yarn is plied yarns twisted together. Thread is hard, fine plied yarn. And cord or cable is many plied yarns twisted into a core structure. That will be strong one. And next objective is different yarn numbering system. Different yarn numbering system. In previous slide, we found that there are different types of yarns. Yes or no? Yes. So the thickness is a very important property of the yarn. So there are methods to determine or define yarn thickness. Depending on the units used for measuring length and mass, fineness of the textile yarn is given. It's in different units. Some systems having different units employed to indicate fineness are called yarn numbering system. So what is yarn numbering system? Some systems have different units employed to indicate fineness are called yarn numbering system. There are two types of systems. That is, yarn number system is having two types. So first one is the direct system. Direct system is nothing but mass per unit length. Indirect system is the length per mass. That is unit mass. Vice versa. Direct is mass per unit length and indirect system is length per unit mass. So, direct system. In direct system, it's classified again text system and linear system. Text system is this system represents the weight in grams per thousand meters length. That is 1000 meters weighs in grams. What is text system? This system represents the weight in grams per 1000 meters length. And linear system. This system represents the weight in grams per 9000 meters. That is 9000 meters weight in grams. So linear system represents the weight in grams per 9000 meters. Whereas in text system it is only 1000 and where in the linear system it is 9000 meters called as linear system. And this is about direct system. And indirect system. Indirect system is count system or metric system. Count system is in the system. Count refers to the number of hanks. That is, one hank equals to 840 yards in 1 pound. This system is called English system as well. So, what is count system in English? That is, count refers to the number of hanks. That is, one hank equals to 840 yards in 1 pound. This system also called as English system as well. Coming to metric system, it is the number of unit length of 1000 meters is 1 kilogram. Metric system is also abbreviated as capital N M small m. And count system is capital N and small e, where N is count and E is the English system, and N is a metric, N is a count, and M is a metric system. So it is a number of unit length of 1000 meters is 1 kilogram. That is about metric system. So what is yarn number system? Yarn numbering system is nothing but it is going to employ to indicate the fineness of the yarn. by yarn numbering system, and it is divided into two: direct system and indirect system. And direct system, it is having text system and linear system, and text system is represents the weight in grams per thousand meters in length, and linear system represents the weight in grams per 9,000 meters length. And met- in that system, it is having two, that is count system and metric system. And count system is, the count refers to the number of yarn one hank equals to 840 yards in 1 pound. And this system is also called as English system as well. So that's why the abbreviation is capital NE is a English system. And a metric system, there is capital N, M is a small m is a metric system. And here is a number of unit length of 1,000 meters is 1 kilogram. What is definition of yard count? Definition of yarn count. We can define yarn count as the coarseness or fineness of yarn. It is just a numerical expression. There are these are main two types of yarn count measuring system. One is direct count and another is indirect count system. So actually, what is yarn count? Yarn count is defined as coarseness or fineness of yarn. It is just a numerical, also called as numerical expression. And these are main two types of yarn count measuring system. One is direct count and another is indirect count. So we can measure the yarn count from the following formula. Yarn count is equal to 590.5 into 16.1 divided by SL into gray GSM yarn appearance. So further in production, we can know what is L, SL and gray GSM. So basic is needed in first semester. Then next, table. We can see in the table numbering system, unit of length and unit of weight. So coming to English cotton count, 840 yards in unit length, then 1 pound is unit weight. And metric count, 1000 meters, 1 kg. Woolen count, 250 yards, 256 yards, 1 pound. And woolen count, 1 yard, 1 ounce. Worsted count, 560 yards, 1 pound. And linen count, 300 yards, 1 pound. So what the table is saying, that is number system it is just given, and unit of mass and unit of weight. So in the English cotton count, 840 yards is equal to 1 pound, and metric count, 1000 meters or one kilometer, that is 1 kg. And woolen count, 256 yards, 1 pound. And woolen count, 1 yard, 1 ounce. Worsted count, 560 yards, 1 pound. And linen count, 300 yards, 1 pound. And what are the quality parameters of yarn it is going to have? So the quality parameters of yarn are yarn appearance, by saying that how we are going to see the quality, by yarn appearance, by yarn evenness, linear density of yarn, count test, single thread strength tester, least strength tester, principles of textile testing, and twist testing. So by this all checking, by all these parameters, we can say it is in good quality. So I'm repeating, the quality parameters of yarn are yarn appearance, yarn evenness, linear density of yarn, count test, single thread strength tester, least strength testing, principles of tensile testing, and last is twist testing. The next, so by this, the unit 2 yarn manufacturing is completed. So far in second unit yarn manufacturing, we learned about how the yarn is going to obtain and what are the process stages, and we have learned the basic terms in spinning. And in this class we have learned the elements of spinning, that is a classification of yarns, how it can tell, how it is going to obtain, and how by twisting the yarns or the combination of yarns, or what we can call like mono yarn, monofilament, staple yarn, etc. And a different yarns numbering system. That means we can express the fineness or coarseness or good yarn by yarn numbering system. In this again we are having direct and indirect. Direct we are having text and linear system, and in that we are having count, English count, and metric system. So finally we have learned about what are the parameters. We have learned the table, how it is going to express in numeric system, that's length and weight. And finally in this chapter we completed by knowing the quality parameters of yarn. So by this chapter 2 yarn manufacture is completed, and today we are going to start the third chapter, elements of fabric manufacture. In first unit, we learned all the definitions. In second unit, we learned how the yarn is obtained. In third unit, we are going to learn how the fabric is going to obtain. So, so fabric manufacture, earlier it is known as weaving. Weaving main article is power loom. At this point, the thread is woven. Depending on the era, one person could manage anywhere from 3 to 100 machines. In the mid 19th century, 4 was the standard number. A skilled weaver in 1925 would run 6 Lancashire looms. As time progressed, new mechanisms were added that stopped the loom any time something went wrong. The mechanism checked for such things as a broken warp thread, broken web thread, the shuttle going straight across, and if the shuttle was empty. Automatic looms could be operated by one skilled worker. So in the further topic, we are going to learn what is weft, what is warp, and what is shuttle. So this is about introduction of weaving. So introduction of weaving is nothing but main article is power loom. At this point, the thread is woven. Depending on the era, one person could manage how many looms? 3 to 100 machines. In the mid-century, 4 was the standard number. A skilled weaver in 1925 would run 6 looms at a time. So, as time progressed, new mechanisms were added that stopped the loom anytime something went wrong. So, the mechanism checked for such things as a broken warp thread, broken web thread, the shuttle going straight across, and the shuttle was empty. The automatic looms could be operated by one skilled weaver. Methods of fabric manufacture. So in the earlier topic, we I told about warp weft. So what is warped broken thread we are going to learn in coming topics. So methods of fabric manufacture are weaving process uses a loom, just like in blow room. In yarn, we are going to have a sequence. Machines are blow room cutting like that. To produce a fabric, we need a loom. The length way threads are known as warp, and the cross way threads are known as weft. The warp, which must be strong, needs to be presented in a loom on a warp beam. The weft across the loom in a shuttle that carries the yarn on a pern. These perns are automatically changed with the loom. Thus, the yarn needs to be wrapped onto a beam and onto the perns before weaving on can commence. So, methods of fabric manufacture is generally weaving process needs to get a fabric from a loom. So, lengthway threads are known as warp and crossway threads are known as weft, and the warp, which must be strong, needs to be presented on a loom to a loom on a warp beam, and the weft passes across the loom in a shuttle that carries yarn on a pern. These perns are automatically changed by the loom. Thus, the yarn needs to be wrapped onto a beam and onto print onto perns before weaving can commence. And you can see the picture of it. See here. So these are the warp yarns and these are the weft yarns. So parallel lines are warp and weft is a perpendicular one. Now we are going to learn the process stages of, okay, where we are uh, winding. Winding. After being spun and plied, the cotton thread is taken to a warping room where the winding machine takes the required length of yarn and winds it onto a warper's bobbins. So, how the length of the yarn is going to obtain? So, warping on beaming. A warper racks of bobbins are set up to hold the thread while it is rolled onto the warp bar of a loom. Because the thread is fine, often three of these would be combined to get the desired thread count. So sizing. So methods of what I am telling, these are all methods of fabric manufacture. So to get a loom, we require what? First one is winding to get the yarns, that is weft yarns, and warping. Warping is warp yarns, also called warping or beaming. And sizing. Sizing is slasher sizing machine needed for straightening the warp by adding starch to reduce breakage of yarns. So generally it is going to apply to warp yarn only. So warp yarn, by applying warp yarn, the starch, it is going to reduce the breakage of the yarns. So sizing should be done. Then drawing in or looming. This process of drawing each end of the warp separately through the dents of the reed and eyes of the hills in order indicated by the draft. Then purning, that is processing the weft. Pern binding machine was used to transfer the weft from cheeses of yarns onto the perns that would fit into the shuttle. So the warp yarns are going to come from warp beam and weft yarns are going to come from shuttle. So next one objective is we are going to see the flow chart of weaving preparatory process. So this is the sequence of weaving preparatory process. Just like in yarn, we are having the sequence what? Blowroom, carding, combing like that. So for weaving also there is a sequence. First one is how the yarn is going to come. The yarn is going to come from, so see the starting portion. Starting this one here. That is yarn from spinning section. From spinning section the yarn is going to obtain. From that is it is going to give doubling and twisting. Then binding. Binding is what? Just how I told about what is binding. Binding is after being spun and plied, the cotton thread is taken for a warping room where the binding machine takes the required length of yarn and binds it onto warper's beam. So that is binding. That means whatever the warper is, whatever the length of the yarn we are going to require, that is going to bind onto the warper's bobbins. That is called binding. Then it is classified into two. First one is warp yarn preparation and weft yarn preparation. So it is classified into warp yarn preparation and weft yarn preparation. So binding is classified. So warp yarn preparation is again is going to prepare cone winding, then creeling, then warping, then sizing, then winding on weaver's beam, then drawing, denting, looming. Then it goes to weaving. How it is going to get weaving? Weaving is the interlacement of warp and weft. So weft yarn is again classified into conventional loom and for modern loom. In conventional loom, it is having shuttle loom, pern binding, and for modern loom, shuttless loom, cone winding. By this, it is going to interlace with weaving. See here, all joined together, we are going to get weaving. That is inspection of after weaving is nothing but interlacement of warp and weft, and inspection of grey cloth. Then again folding, then packing and delivering. So this is the sequence of fabric manufacture. So the yarn is going to come from spinning section. It is going to give doubling and twisting, and it is going to get binding. That is, binding is how much the length of the yarn we are going to need in the preparation of fabric, that it should be going to wound on a bobbins. Again, it is divided into warp preparation and weft yarn preparation. In warp yarn preparation, we are going to prepare cone winding, from then to creeling, then to warping, then sizing. Warping is warping beam. Sizing is we are going to apply the starch to reduce breakages. Then binding on weaver's beam. Then drawing, denting, looming. And in weft yarn preparation, it is having for conventional loom and for modern loom. In conventional loom, it is having shuttle loom, that is pern winding, and shuttless loom, that is cone winding. Then by interlacing both, we are going to get weaving, and after getting fabric, we are going to inspection of free cloth, then folding, then packing, deliver. This is the sequence of fabric manufacture. Then process stages of weaving preparatory. There are three primary movements of loom are shedding, picking and beat up. So first process of weaving preparatory shedding. The operation of dividing the warp into two lines so that the shuttle can pass between these lines. What is shedding? Shedding is the operation of shedding, drawing the or dividing the five warpians into two lines so that the shuttle can pass between these lines. These are two general kinds of sheds, open and closed. Open shed, the warp threads are moved when the pattern requires it from one line to the other. Closed shed is the warp threads are all placed level in one line after each pick. This is a shedding. And coming to picking. Picking is the operation of projecting the shuttle from side to side of the loom through the division in the warp threads. This is done by the overpick or underpick motions. The overpick is suitable for quick running looms, whereas the underpick is best for heavy or slow looms. Then third operation is beat up. The third primary movement of the loom when making cloth and is the action of the reed as it drives each pick of weft to the fell of the cloth. And you can see the diagram. This is reed, this is warp, this is a shuttle, this is weft, and this is a cloth. So the line, so these are the parallel lines, also called as warp. This is a weft. Weft is going to come from shuttle, and this is a reed. It is going to make separation, and this is a cloth. This is a shedding. This is a picking. Picking is insertion of weft yarn through shuttle, and beat up. Beat up is, see here. You can see the shuttle is the action of the reed as it drives each pick of the weft to the fell of the cloth. This one. This is the beat up. So these are the three motions of the weaving. So what they are? Shedding, picking and beat up. So shedding is what? Shedding is the operation of dividing the warp yarns into two lines so that the shuttle can pass between the lines. And picking is the operation of projecting the shuttle from side to side of the loom through the division of in the warp threads. This is done by overpick and underpick motions. Overpick is suitable for quick running looms and underpick is used for heavy and slow looms. And finally beat up is nothing but it is action of the reed as it drives each pick of weft to the fell of the cloth. So you can see here first A I have given that is shedding, this is picking and this is beat up. In shedding you can see the weft yarns, warp yarns, shuttle, reed and cloth. And here in picking you can observe the shuttle insertion of weft yarn and this is each reed, the action of the reed as it drives each pick of the weft to the fell of the cloth. So these are the three process stages of weaving. The definition of basic terms in weaving like warp and weft already we learned. So already the yarns are going to place parallelly. The length way are called warp and the weft yarns by shuttle it is going to insert through reed is called the crossway threads are known as weft. So these are the objectives of today's class. So the elements of fabric manufacture we learned. So generally the fabric is also called as weaving. Weaving is the main article is power loom. At this point the thread is woven. Depending on the era, one person could manage how many? 3 to 100 machines. In the 19th century, 4 was the standard number. A skilled weaver in 1925 would run 6 looms. As time progressed, new mechanisms are added that stopped the loom anytime something went wrong. These mechanisms checked for such things as the broken warp thread, broken web thread, shuttle going straight across, and if the shuttle was empty. Automatic looms could be operated by one skilled worker. Methods of fabric manufacture is weaving process uses a loom. The lengthway threads are known as warp and crossway threads are known as weft, and the warp, which must be strong, needs to be presented to the loom on the warp beam by applying the starch called sizing. The weft passes across the loom in a shuttle that carries a yarn or a pearl. These pearls are automatically changed by the loom. Thus, the yarn needs to be wrapped onto a loom, that is beam, and onto the pearl before weaving commences. Then in winding, after being uh, spun and plied, that is coming the yarn from spinning section, the cotton thread is taken to the warping room where the winding machine takes the required length of yarn and winds it onto warper's bobbins. Warping or beaming. A warper. Racks of bobbins are set up to hold the thread while it is rolled onto the warp bar of a loom. Because the thread is fine, often three of these would be combined to get the desired thread count. The slasher sizing machine needed for straightening the warp by adding starch to reduce breakage of the yarns. Drawing in and looming. The process of drawing each end of the warp separately through the dents of the reed and the eyes of the hills in order to indicate it by the draft. Purning, crossing of the weft. Palm winding frame was used to transfer the weft from cheeses of the cone onto the perns that would fit into the shuttle. This is the flow chart or sequence of the fabric manufacture or weaving preparatory. So first the yarn from spinning section, then to doubling and twisting, then winding. Again winding is divided into warp yarn preparation and weft yarn preparation. In warp yarn preparation we are again is going to obtain cone winding reeling, then warping, sizing, binding on weaver's beam, drawing, denting, looming. And in weft yarn preparation the Abaptian is going to prepare from for conventional loom, shuttle loom, pawn winding, and for modern loom, shuttless loom, that's pawn winding. By combining these two warp and weft yarn, we are going to get interlacement of warp and weft, also called as weaving. That is inspection of grey cloth. then folding and packing and delivery. This is a sequence of the fabric manufacture or weaving preparatory. Then process stages of weaving preparatory are shedding, picking, and beat up. So shedding is the operation of dividing the warp into two lines so that the shuttle can pass between these lines. These are two general kinds of sheds, open and closed. Open shed is the warp threads are moved when the pattern requires it from one line to the other. Closed shed is the warp threads are all placed level in one line after each pick. That is open shed and closed shed. Coming to picking. Picking is the operation of projecting the shuttle from side to side of the loom through the division in the warp threads. This is done by the overpick or underpick motions. The overpick is suitable for quick running looms, whereas the underpick is best for heavy or slow looms. And beat up. The third primary movement of the loom when making cloth and is the action of the reed as it drives each pick of weft to the fill of the cloth. And you can see here warp, weft, cloth, reed, and shuttle. And this is the shedding, this is the picking, and this is the beat up. And definition of basic terms in weaving are warp and weft. So warp is, you can see in the picture, the lengthway threads are known as warp and weft is the crossway threads are known as weft. So by this, today's class is completed. Before completing the today's class, what the objectives we have learned here are: in yarn numbering system, yarn manufacture, we learned about classification of yarns, different yarn numbering system, definition of yarn count, the quality parameters of yarns. In elements of fabric manufacture, we learned methods of fabric manufacture, flow chart of weaving preparatory process, then process stages of weaving preparatory, and basic terms, definitions in weaving like warp and weft. Generally, the yarn is obtained by the fiber length yarn construction by spinning a system in filament yarn and staple spun yarns are classified into mono, multi staple spun yarn. Monofilament is solid single strand of unlimited length and many continuous filaments with some twist is called multifilament. And staple yarn is many short fibers twisted together tightly is called staple yarn. And two-ply yarn is two single yarn are twisted together. And multiplied yarn is plied yarns twisted together. And thread is hard, fine plied yarn. Cord or cable is many plied yarns twisted into a core structure that will be strong. Different numbering system. In previous slide, we found that there are different types of yarns. So thickness is very important property of the yarn. So these are the methods to determine or define yarn thickness or yarn fineness and yarn numbering system. It is going to employ to indicate fineness of the yarn. There are two types: direct system and indirect system. Direct system are mass per unit length. Indirect system is length per unit mass. Indirect system, where they are having two types: text system, linear system. Text system is, this system represents the weight in grams per thousand in meters, and linear system is, this system represents weight in grams per 9,000 meters. And in that system, it is having count system, also called as NE. NE is a unit system, and a metric system, and M is a metric system. Count system is, in this system, count refers to the number of hank. That is, one hank equals to 840 yards in a 1 pound. This system called English system. And in metric system, the number of unit length of 1,000 meters is 1 kilogram. And definition of yarn count is, yarn count, we can express the yarn count as coarseness or fineness of the yarn, and is also it is nothing but numerical expression. And there are mainly two types of yarn counts measuring system. One is direct count, and another one is indirect count system. And we can measure the yarn count from the following formula: yarn count is equal to 590.5 into 16.1 by divided by SL. SL is nothing but span length into gray GSM, that is gram square meter. And yarn appearance, and you can see the table, that is numerical numbering system, unit length, that is L, and unit of weight, W. English cotton system, that is NE, that is 840 yards, 1 pound. And metric count, NM, 1,000 meters, 1 kilometer, 1 kg. And woolen count 250 yards, 1 pound. And woolen count 1 yard, 1 ounce. Worsted count 560 yards, 1 pound. And linear count 300 yards, 1 pound. And finally, to know the quality parameters of yarn, we have to check by all these parameters, and we can say that is in good quality. That is, the parameters are yarn appearance, yarn evenness, yarn linear density of yarn, count test, single thread test and testing, least strength, principles of tensile testing, and finally twist testing. So by this, the unit 2 is over, and unit 3, four topics we have covered. We are going to know in this chapter the elements of fabric manufacture. We learned the introduction, what is weaving, and what are the methods to get fabric, that is winding, sizing, all these things. And next we have learned the sequence of a weaving manufacture, fabric manufacture. And next we have learned the process stages of a weaving manufacture, that is shedding, picking, and beat up. And finally we have learned the basic terms of warp and weft, that is warp is a parallel way, lengthwise is called warp, and weft is a cross way, perpendicular. So by this, that today's class is completed. Thank you.